Hi there, welcome. Today we're going to learn a little bit more about the chain rule. And so we're going to start with just some basic questions. And the first question, which rule would be used to find the derivative of that function? Give me a second. Alright, and the answer hopefully that you came up with is that we'd use the power rule. It was just straight, everything to a power and boop, 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 and we could get that answer easily. Let's go to the next one. Which rule could we use to find the derivative of this function? Alright, hopefully you recognize that it's the product rule, first and foremost. And within the product rule, we'd have to use our power rule. So we can end up using a couple of different rules as we're working our way through these various derivatives as we go. Alright, how about this one? Which rule would we use to find the derivative of the function? Alright, so how many people said the quotient rule? There's an easier way. This is one of those STDs, so if we treat it as an STD, we can break it down, make it a much easier function to deal with, and then only have to use the power rule. Quotient rule would work, but it'd be a whole lot more work, so we don't want to necessarily do more work. We want to work smart, not hard, if we can. Alright, so next one. How about that one? How many people said the quotient on this one? That would be a good guess. The quotient rule would be a delightful thing to use here. It would get you through ho-de hi minus hi-de ho over ho-ho, that sort of thing would get you there. And of course, within the quotient rule, we would certainly be using our power rule as we go. All right, next one. How about here? Which rule would be used to find the derivative of that function? The tangent of 3x squared plus 7x. All right, so I would say that we are definitely using the chain rule. Okay, because first we'd find the derivative of tangent, which is secant squared, and the secant squared of 3x plus 7x, not changing the argument at all, and then we'd multiply that by the derivative of 3x squared plus 7x, which is 6x plus 7, and that would be our derivative in this case. Remember, when it's written this way, this is not mean tangent times that, it's the tangent of, and I know a lot of times of means multiplied by, but in this case it's just the tangent of. We never change the argument, so never, 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 never would we use the product rule in a situation like that. Okay, how about the next one? Ooh, sine squared. So take a second, think, which one would you use? And of course, it could be more than one. Alright, so if you said the power rule, that would be part of the answer. If you said the chain rule, that would be the other part of the answer. Because remember, this is one of those PTA things. So we start with the power, and then the trig piece, and then the argument. And we'd quickly rewrite this if we did as the sine of 6x cubed minus 5x squared, like that. And then we'd use our power rule first, and so it would be 2 sine 6x cubed minus 5x. And then we'd use the trig derivative, and so we'd multiply this by the derivative of sine, which is cosine of 6x cubed minus 5x. And then we multiply by the derivative of the argument, which in this case is 18x minus 5. And I'm not going to make it look nice, but bring this, connect that with 2, sine, cosine, so forth and so on there. All right. How about this one? Okay. Hopefully you said this would be a chain rule situation, and within the chain rule, we'd be using the power rule, really twice, right? So we'd have 5 something to the 4th, and then the derivative of the something, right? So that should be fairly straightforward. How about this guy? Don't be frightened. So we notice that it's two things multiplied together, so we're definitely using the product rule. Okay. We notice, though, that each one of these things is raised to a power, so we're definitely going to have to use the chain rule and the power rule. So everything with the quotient rule on this particular one here. So a little more complicated to do. How about here? Which rule would be used? Getting worse and worse, getting more scary as we go. Alright, so it's a quotient. There's no way to simplify that, so we're definitely going to use the quotient rule. It's got exponents in it, so we're definitely going to use the power rule. And because we're doing all this this stuff here, we're definitely going to use the chain rule as well. Okay, so here's the big picture. Here's the payoff. It's the chain rule. and we have some special guests this week, the product rule and the quotient rule, joining in to make the chain rule all that much more fun, to be able to really take the derivative of probably the most complicated functions we're going to see all the way through the semester. So we're going to go back in detail on those problems that I just showed you, how to work through the derivative on that. So we said we're going to use the product rule. So we're going to use the product rule, and so with the product rule, the first times the derivative of the second. So we need the derivative of all of this stuff over here, and so we're going to use our power rule first for something to the third power times the derivative of that something, and the derivative of 2x cubed is 6x squared. The derivative of 5x squared is 10x, and so that's the first times the derivative of the second plus the second, and so we just write down the second times the derivative of the first, and so the derivative of the first, again, it's something squared, so the derivative of something squared is 2 something to the first power, and we don't write down the first power, times the derivative of that something, 6x plus 7. Close that. We probably want to make this look nice, and really the only thing that I would have you do is I would have you bring this 4 out to the front of these terms, and I'd probably have you bring this 2 out into the front of those terms. I wouldn't necessarily multiply any of this together. I'd just have a bunch of terms and just have the constants out in the front so they don't get lost in the mix, okay? So there's that one. Then there's this one. How do we do this? This is going to be the quotient rule, okay? So quotient rule, so O T high minus high T ho over ho-ho. So the bottom part's easy. We can do the ho-ho part really quick. It's always my favorite part to do. 4x squared minus 3. It's already to the 4th, so if we square that, it's going to be to the 8th. Okay, because you do the exponent thing. So now we're going to do the ho, which is the bottom part. 4x squared minus 3 to the 4th. D high, what's the derivative of sine of 2x? Well, the derivative of sine is cosine of 2x, and then we need to multiply by the derivative of 2x because of the chain rule, which is 2. And I always put that 2, again, out in the front so it doesn't get confused. So ho, d high, minus high, d ho. And parentheses are great. You can't use too many of them. They're free. D ho. So the derivative of this part. So it's something to the 4th power, so it's 4, that same something, to the 3rd power, and then times the derivative of that something, which is 8x. Okay? We should probably try to make this look a little nicer because it's just not pretty. And so, let's see, I would probably go 2 cosine 2x times 4x squared minus 3 to the 4th minus 8x. Nope, how about, oh, too bad, forward. How about, edit that out a little later. How about, still in red, 8x times 4, how about 32x times sine 2x times 4x squared minus 3 cubed all over 4x squared minus 3 to the 8th power. We could probably factor these out and reduce it with some of this. You know, we could factor out cubed and bring that down to the 5th, but we're okay for right here for right now. It'll be fine. So, there it is. Chain rule with trig. Look at this one. Here's what I'm going to do. I'm going to have you work through this one by yourself right now and check in with me a little later for the answer. Alright, so you want some help on this one. This is going to be a power rule and a quotient rule all wrapped up into one. And so if I grab a different color pen, just for fun, 3 times x squared plus 3x over 2x minus 5 squared, okay? Because it's something cubed, so it becomes 3 something squared, and then we're going to have to use the quotient rule to get the other part. So the bottom of the quotient rule, I start with that first because it's easier, And then we just do a ho d high minus high d ho. So ho is 2x minus 5. D high is 2x plus 3 minus high x squared plus 3x. D ho is 2. And then we got to do some work to make this look nice, particularly this part here. It's sort of, we can simplify that because it's simple polynomial stuff. So I've got 3 times x squared plus 3x over 2x minus 5 squared. And then here, let's see, this is going to be 4x squared minus 10x plus 6x minus 15 minus 2x squared minus 6x, check that for me please, over 2x minus 5 squared. And then probably I would go, what's that going to be, negative, let's see if we can make that all look nice. Let's see, 4x squared minus 2x squared, so you're going to have 2x squared, negative 10, oops, those neutralize each other, so that's good, so minus 10x minus 15 over 2x minus 5 squared, don't know why I'm resisting the extra page, times that. And that's about as far as I would take this particular little thing right there. Your final answer is what's down here in the box. I could try to write it neater, but I don't know if I can. That's how we get to the final answer. So there's my box page. That's the problems that you're going to work on with this. So hopefully this makes some sense. The chain rule gets a little more complicated as we go. There's lots of opportunity for you to practice, and that's really what you just need to do. Is you just need to keep practice, slow down, figure out what rules you're going to use them appropriately. Don't try to do too many things at once. Show lots of layers, show lots of work, simplify as far as you can, or as far as you think is prudent, and go from there. All right. So thanks for watching. Hope you learned something, and we'll talk to you real soon. Bye.